KD Supply Operations is responsible for the export of components to overseas locations for use in assembling Ford European-designed vehicles. Due to reduced customer demand and increased competition, KD had lost considerable business. The operation had implemented a successful cost reduction program, but the overseas competition, particularly with respect to quality of service to the customer, was as strong as ever. Many of the more usual actions were taken, but having heard about the successful use of statistical process control in other areas of the company, a process improvement team was formed. They selected a problem to investigate that affected all of them. Ford Venezuela assembles approximately 20,000 Sierras per year. 70% of the components used in these vehicles are supplied from Europe through KD operations. Parts requested by Ford Venezuela are manufactured by a variety of Ford plants and Ford component suppliers and delivered into H Building on the Dagenham estate. The information on the delivery document is input into the computer, which authorizes payment to the supplier and enters the parts onto KD's stock inventory. The computer then generates a pallet tag, which identifies the part number, the quantity, and the date they were received. The inspector checks that the data on the pallet tag corresponds to what has been received and attaches the tag to the pallet. Discrepancy reports will be raised to correct any errors discovered at this stage. The pallet tag controls the components through the entire packing and shipping process. When a component is packed into a case or container, a portion of the pallet tag is torn off. This acts as the input document to Invoice Venezuela. It releases the parts from KD's inventory and advises Venezuela each day of the parts that have been shipped. It is on this information that Venezuela bases its production plan and schedules. Missing parts are parts which have been received for shipment to Venezuela, but records show that they've not subsequently been shipped.
Now that causes me some concern. How long can you keep running for? Well, what I'll do, Ozzy, I'll check down on the shop floor just to make sure that we haven't already shipped it. Then I'll contact Body Group, check on the availability.
Discrepancies arising from the process can result in significant inventory problems in Britain and Venezuela, as well as substantial increases in costs due to assembly line stoppages and panic air freight shipments.
If Body Group have got them available and it's just a question of shipping them down the road, I can get them in the air first thing in the morning.
And that is going to be the first vulnerable point where we can make mistakes, it seems to me.
The process improvement team decided that in order to establish exactly what their problems really were, they all needed a better understanding of the process itself. The team developed a process flow diagram to document the entire receiving, packing and shipping process and examine the process in detail, step by step. This involved looking closely at what was actually happening during the process and identifying any weaknesses or potential problems. This proved to be a highly informative part of the exercise. All members of the team learned a great deal further about the process, even those who had direct responsibility for certain parts of it. Statistical control charts were developed to record the number and frequency of the receiving and shipping discrepancies. Analysis of these charts established a meaningful indication of the limitations of the present process. It was obvious at this stage that there were many aspects of the process that had potential for improvement. The team developed a cause and effect diagram where, combined with other information about the process, they were able to identify and categorize the possible cause for each discrepancy. These causes were analyzed further using the Pareto analysis technique, which highlighted a number of major causes. By far the most significant problem was the failure to remove the tear-off portion of the pallet tag before shipment of the parts. This meant that the parts were shipped, but not recorded in the computer as being sent. These parts were therefore assumed to be missing. The team concentrated their efforts on this major cause, and following a number of brainstorming sessions, positive actions were taken in their endeavor to improve the process. Actions such as using a contrasting color for the tear-off portion of the pallet tag. A simple idea, but a very effective one, that would clearly indicate if a pallet had been packed without first removing the tag. By ensuring that all tags are pulled, the correct information is now logged into the computer, and the invoice Venezuela receives corresponds exactly to the number of parts shipped. This single action alone resulted in a significant improvement to the process, which was reflected by the control chart the team had developed. The chart immediately showed a drop in the number of missing parts. The use of a different colored sticker on the pallet tag was introduced in order to clearly identify the date each pallet was due to be shipped. This system ensures that all pallets with the same colored sticker are easily selected and placed in specially designated dropping zones identified by the same color. The introduction of these stickers and zones ensures that the customer is shipped only what is required according to a predetermined schedule. In other words, Venezuela only get what they want when they want it, thereby reducing the inventory problems, assembly line stoppages, and panic air freight shipments. Having made these very successful changes to the process, the team directed their attention to the next major cause of missing parts, highlighted by the Pareto analysis, that of arithmetical errors. These errors were generated, for example, when deliveries of components had to be divided into smaller consignments, or through human error when inputting information into the computer. Improvements to these and other areas of the process were made by making modifications to the computer system. The system now calculates quantities and cross-checks previous data, thereby reducing the need for arithmetical calculations by the operator. The team were able to use the control charts to monitor the effect each change had on the process and decide upon the implementation of the change or otherwise. Throughout the exercise, the team recognized the importance of everybody understanding what is expected of them and what is required by the person who is next in line in the process, their customer. They embarked on an improved training program to ensure that everybody understood the part they had to play in the process and the significance of any errors they made. The success the team had has promoted a wider awareness of the potential for improving any process through statistical thinking. Within a year of establishing the first process improvement team, 6 others were operating within KD. Instead of just living with their problems, they are now solving them. But they haven't stopped there. They're looking at ways of improving their process even further and have proven the value of continuous process improvement.